Hi, welcome to today's lesson. What we're going to be looking at today is the derivation of the quadratic formula. Okay, the derivation of the quadratic formula. Right, now you know the quadratic formula because you should have seen it by the time you've come to here. The quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Okay, I've written that really small because there's lots of references to it everywhere. It's just so that I've got something to talk about. So this is what x equals when you set the whole quadratic equal to 0. It's the roots of the quadratic. Okay, now it's quite useful, I think, to understand where that comes from. So let's look at how we get there. If I've got something like this, ax squared plus bx plus c, and I want to find out what is x to make this equal to 0. So I want this whole thing equal to 0. Now, here's what I'm going to do. I'm going to leave the variables in, so I'm going to leave the letters in, and I'm going to complete the square on this. Okay, and the thing is, it shows you where that comes from, which I think is useful to understand, because it also leads on to understanding a little bit about the graph. Right, so let's take a look at this. First thing I notice, I can't do anything when a is not 1, so I have to factorize out of a. So let's complete the square just on the x parts. Let's leave c there for now. So just on these x parts. Firstly, I'm going to pull out an a. Okay, so I'm going to pull out an a. And if I'm pulling out an a, that means that just on the x parts, plus c equals 0. Like that, right? Well, I pull out an a over there, I've just got x squared. Plus, if I pull out an a from b divided by a, I've got b over a times by x. Alright, so that's now, this coefficient is 1, which you have to complete the square. Alright, fantastic. Well, let's leave this a over here, alright? And let's now complete the square on the x parts. Plus c equals 0. Alright, so if I complete the square on the x parts, I've got x, same sign, plus half of that. Half of b over a. 1 times b is b, 2 times a is 2a. You with me? So plus b over 2a, all squared. Now I have to correct for that error that's coming in when I square this, minus that squared. B squared over 2 squared is 4, a squared is a squared. You're with me? Okie dokie, fantastic. Super. So now, there's a couple of ways to do this. You could either move the c there first and then distribute the a, or you could distribute the a and then move the c there. It doesn't really make a difference. Okay? Let's actually do that quickly. So let's move the c to that side and then get rid of the a, instead of having to times it out and then divide it out later. Okay, so let's get that c to that side. So let's just leave this part as it is. A, alright, brackets, and then inside the brackets, x plus b over 2a, x plus b over 2a, all squared, minus b squared over 4a squared. You can kind of see where it's coming from. It's kind of coming in already. Okay? Equals opposite plus c is minus c. Alright? With me? OTOS, opposite to other side. Okay. Now, let's get rid of this times by a. Opposite times by a is divide by a, right? Remember, I'm using bidmass backwards to figure out what to get rid of next. So if I reverse bidmass on this side, I want to get rid of x. If I reverse bidmass, I can't get rid of this. I have to get rid of multiplication, because this is in brackets. Okay? So, opposite times by a is divide by a. So I've got this on here, x plus b over 2a all squared minus b squared over 4ac, a squared, what am I saying, a squared, right? Equals minus c over a. I've just divided by that a. You're with me? Okay, great. Now we're getting closer there. So now, start on the side, say bidmass backwards, right? What am I going to get rid of first? I'm going to get rid of this. Okay, so let's get rid of this. Opposite minus that is plus that to the other side. So on this side, I've got here x plus b over 2a all squared, right? Equals minus c over a. The opposite of minus b squared over 4a squared is plus b squared over 4a squared. Okay? Plus b squared over 4a squared. You're with me? Okay. I want to make some more space. I'm going to go over to the next page and I'm going to rewrite this. Okay. So, here's what we've got. This is the last line, right? x plus b over 2a squared equals, let's just rewrite that in a nice order, okay? Let's put the minus b, the plus b, b squared over 4a squared minus c over a. You're with me? Okay, great. Now we say, okay, cool. So this, all I've done is just swap the order of this. So it was negative c over a plus b squared over 4a squared, but just swap the order. Right, so let's still keep this here. X plus b over 2a squared. And let's tidy up this side, right? If I find the lowest common denominator, well, the lowest common denominator of anything is just them multiplied together. Well, not anything, most things, most variables, okay? So I say, okay, well, what does he need to be that? He needs nothing. It's just b squared. Same sign, minus. What does c need? What does a need to look like this? Well, he needs times a 4, and he needs times another a. Right? 4ca, or to get the better alphabetical order, 4ac. Can you see it already? Alright. Now let's carry on. Now, the next thing I'm going to apply bit mass backwards to here. I can't get rid of inside the brackets, so I have to go, if I reverse bit mass, I have to get rid of the indice. So opposite square is square root. So I've got x plus b over 2a equals, now the square root of this. The square root of all of this, right? b squared minus 4ac all over 4a squared. Okay. But this square root I can split into two of them, right? So let's do that. Let's bring this across. So I've got x on this side equals minus b over 2a. Are you with me? Okay. And then let's split this square root up here. So I've got, remember, square root is plus or minus, right? The square root of b squared minus 4ac, that's the square root of the top, over the square root of the bottom. Well, the square root of 4 is 2, the square root of a squared is a. Look. Okay, and that's it, we're done. There's a quadratic formula. Now, you could go and put them over the same denominator and just do this. Minus b plus or minus the square root of b squared minus 4ac over 2a. Okay, you can put them over the same denominator, that's absolutely fine. But I want to keep them separate for a second because I want you to notice something. Look, I got a ruler. Finally. Alright, so I want you to quickly just notice something. Take a look if I've got an xy axis. Alright? If I've got a nice pretty xy axis, alright, and I've got a nice pretty parabola. Let's put a parabola that cuts over there, goes down to there, and cuts there. Alright? Now, here's what I want to show you, and this is where the insight comes from, right? The symmetry of this, if you think about this, this is a number, whatever number it is, it's just a constant, negative. This is a number plus some other number. There's only numbers here. These variables stand for numbers. So it's a number plus some number, or a number minus some number. Now if you look at this as the symmetry, right? This minus b over 2a, that's that point. Minus b over 2a, right? That's the point in the center, the turning point, the x value of the turning point of your parabola. Okay. Now, if I say plus some number, well, plus some number is just this side. Plus some number. Plus the discriminant, that's the fancy name of this, the root of the discriminant over 2a. Alright? Or, if I'm going down, minus some number to get to the other root. So plus some difference to get to the top root, and minus some difference to get to the other root. Okay. Now this is quite powerful because this says, okay, well this will give me my root when it's 0, when the whole thing equals 0, or my other root when the whole thing equals 0. But graphically, this is how it ties in. There's my symmetry. There's left, right for plus, and left for minus. Okay. That's fantastic, right? Because it gives you a small insight of its shortcut to find the turning point. Well, what's the x value of this turning point? The x value of this turning point is just minus b over 2a. It's just that, because there's a symmetry. The axis of symmetry is x equals minus b over 2a. Okay, and then all we have to do to actually find the y value is substitute that in. Now when you get into function notation, this is going to make sense. But if I substitute into the function of minus b over 2a, I get out the y value. So this makes it very, very quick to find the turning points and the axis of symmetry for any parabola. I don't have to complete the square if they don't ask me for it, although it's useful to know how to do that, alright? If they ask you to complete the square, please complete the square. Right, but if they don't ask you for it, all I have to do is understand that of my quadratic formula, minus b over 2a is the symmetry points. It's the points across which the whole parabola can fold. Okay, it's symmetrical about that x value. So that becomes then my x value of my turning point. It also becomes my axis of symmetry, x equals that value, whatever that value is. Okay, take b, take a, plug it in, boom, there it is. Okay, quite powerful, huh? I really like that. Now, it's useful to understand this. It's not necessary for what I've never seen them ask this in a test. Okay, I've never seen anyone in any exam where they say derive the quadratic formula. Okay, you might get it as an extension in like extension exams, but really, the only advantage I can really see of this is understanding how it gets there, feeling strong enough in your algebra to actually do it, and then this. This, I think, is a great bit of insight into understanding about what it means from the algebra to the picture. Okay, anyway, go watch this again, go see if with the insight, go practice it, go test it out on a couple of parabolas, take them, put minus b over 2a, find the turning point, draw them and see what you get. Alright, and remember, I'm here for you.